As you gaze upon an aerial view of clouds forming in the sky, have you ever considered the potential for humans to shape the weather? Picture, if you will, human hands guiding the formation of clouds, dictating whether it rains or snows. This isn't a page from a science fiction tale. Welcome to the world of cloud seeding, a weather modification technique that aims to enhance precipitation by dispersing substances into the atmosphere. As you witness the animation of a cloud seeding aircraft dispersing substances into the atmosphere, picture in your mind the process of weather modification. This technique, known as cloud seeding, stimulates formation or precipitation. The aircraft unleashes common seeding agents such as silver iodide, potassium iodide, or liquid propane into the atmosphere. Acting as nuclei, these substances engage with water droplets, initiating condensation or freezing. This interaction leads to the creation of clouds and the potential for rainfall or snowfall. But how effective is this intriguing procedure? The answer isn't as simple as one might think. The success rate of cloud seeding isn't constant. It fluctuates greatly. Some scientific research implies that cloud seeding can potentially boost precipitation in certain scenarios, while others advocate that it has minimal or zero effect. Elements such as the makeup of the cloud, temperature, and levels of humidity can dramatically affect the performance of cloud seeding endeavors. This diagram illustrates how the seeding substances act as the core around which water droplets can condense or freeze, causing the formation of clouds and possibly bringing about rain or snow. Watch closely as clouds form and rainfall ensues in this time-lapse footage. While cloud seeding holds potential for boosting precipitation under specific circumstances, it's also true that its success rate can fluctuate. What about the effects downwind of the seeded area? Here's where it gets complicated. Studies have shown mixed results about cloud seeding. Some have shown increased precipitation in the vicinity of the seeded locations, while others show little to no significant impact. These graphs comparing precipitation levels in seeded and unseeded areas illustrate the point. The potential influence of cloud seeding on downwind weather patterns leads to unintended outcomes such as shifts in precipitation patterns or cloud formation in areas not targeted for seeding. Estimating these downwind effects is vital for mitigating potential impacts. Lastly, we must address the ethical considerations. The capacity to manipulate weather patterns can yield far-reaching results. Decisions about the timing and location for initiating cloud seeding operations must weigh ethical, social, and economic implications. As we conclude, despite numerous years of study, cloud seeding remains shrouded in scientific uncertainty. The ever-changing weather patterns, the intricate dynamics of the atmosphere, and the problematic nature of conducting controlled experiments contribute to the complexity of deriving definitive deductions about the results of cloud seeding. To put it simply, cloud seeding is a multifaceted and debated technique. It potential advantages for the management of water resources and agriculture, but also introduces critical scientific, environmental, and ethical aspects. A continued dedication to research and enhanced comprehension of atmospheric processes are fundamental in evaluating the effectiveness and impact of cloud seeding thoroughly. So the next time you find yourself in an unexpected shower, consider the complicated science and ethical factors behind those raindrops. Or, who knows, it might just be nature taking its course. Visual. Images of cloud seeding equipment and operations flash across the screen. Narrator. Remember, cloud seeding can have environmental consequences, including potential alterations to precipitation patterns and effects felt downwind. In this next scene, let's delve into some real-world applications and case studies of cloud seeding to better understand its practical implications and the extent of its potential impacts. As we transition from the realm of theory to practice, visual aids will be used to enhance understanding. We'll be looking at maps showing downwind impacts of cloud seeding. These maps will illustrate how alterations in weather patterns can occur in areas not specifically targeted for seeding. Voiceover. Cloud seeding has been used in various parts of the world, from the dry plains of Texas to the snowy mountains of Colorado, and even in the densely populated areas of Beijing. Each of these locations has its unique set of circumstances that influence the outcome of cloud seeding operations. The downwind effects of these operations may lead to unintended consequences, such as altered weather patterns in areas not targeted for seeding. This further underscores the need for comprehensive research and careful consideration before implementing cloud seeding on a large scale. Visual maps highlighting the mentioned areas and potential downwind effects. Narrator, in our next scene, we will delve deeper into these case studies, examining the specific outcomes and lessons learned from each. Stay tuned as we explore the world of cloud seeding beyond the lab. In this scene, we will be highlighting the ethical dilemmas associated with cloud seeding. As we have seen, cloud seeding can have profound effects on weather patterns, not only in targeted areas, but also in regions downwind. This brings us to a critical question. To what extent should we intervene in natural processes, especially when the consequences can be unpredictable and far-reaching? Cloud seeding, like any other human intervention in nature, raises several ethical dilemmas. For instance, who gets to decide where and when to seed clouds? What happens if a region downwind of a seeding operation experiences flooding or drought as an unintended consequence? And who bears the responsibility for these outcomes? Visual animation depicting a cloud seeding operation, then transitioning to a scene of flooding and drought in different regions. Narrator, these questions underscore the need for careful regulation and oversight when it comes to cloud seeding. They also highlight the importance of comprehensive research into the potential unintended consequences of such interventions. As we continue to grapple with these issues, the debate around cloud seeding is likely to become even more complex and nuanced. Visual animation depicting researchers studying cloud seeding, followed by a scene of a heated debate among various stakeholders. Narrator, in our next scene, we will look into the future of cloud seeding and its potential role in addressing global challenges such as climate change. Stay tuned as we explore the future of this fascinating technology. As we look ahead, it's clear that cloud seeding could play a significant role in addressing some of our planet's most pressing challenges. However, achieving this potential won't be without its hurdles. Visual animation of a scientist analyzing data and conducting research on cloud seeding. Narrator, ongoing research is essential for improving our understanding of cloud seeding and its long-term impacts. This includes not only understanding its effectiveness, but also studying its potential side effects and how to mitigate them. Visual animation of a cloud being seeded, followed by a depiction of weather patterns changing. Narrator, as our climate continues to change, cloud seeding could become a critical tool for managing water resources and mitigating the effects of drought. But to use this tool effectively, we must ensure that it doesn't exacerbate other environmental problems or create new ones. Visual animation of a dry landscape transforming into a lush green environment after a rainfall, followed by a scene showing a cloud seeding operation causing unintended environmental changes. Narrator, the future of cloud seeding is indeed promising, but it's also fraught with uncertainty. As we continue to explore this technology's potential, it's crucial that we keep questioning, researching, and debating. Only then can we hope to steer cloud seeding in a direction that benefits us all. Visual animation of a group of scientists engaged in a discussion, followed by a scene showing a cloud seeding operation being carried out responsibly and ethically. As we wrap up our exploration of cloud seeding, it's important to remember that this technology is just one piece of the puzzle when it comes to tackling our planet's climate challenges. Visual animation of a puzzle with pieces representing various climate solutions, including cloud seeding. Narrator, while cloud seeding offers potential for alleviating water scarcity and mitigating drought impacts, it's not a silver bullet. It must be used responsibly, with a thorough understanding of its effects and a commitment to ongoing research and ethical oversight. Visual animation of a balanced scale representing the pros and cons of cloud seeding. Narrator, as we look to the skies for solutions, we must also remember to look within, to our own actions and choices. Visual animation of a person looking up at the sky, then turning to look at a reflection of themselves. The future of our planet depends on our ability to innovate, adapt, and most importantly, to act with responsibility and foresight. Visual, animation of a globe surrounded by diverse people working together, symbolizing global cooperation. Narrator. And so, as we continue to experiment with cloud seeding and other techniques to manipulate our climate, let's remember the importance of balance, respect for our environment, and the pursuit of knowledge. Visual, animation of a cloud seeding plane flying through the sky, followed by a scene of a scientist studying cloud